All right, this is the review for the 3-1 to 3-3 quiz. And we have, let's graph 3 to the x. So 3 to the 0 is 1, 3 to the first is 3, 3 squared is 9. Now negative on the outside of the function reflects over the x-axis. So there it is, there's reflected over the x-axis. And then 1 up. Well, if you're going to push an exponential 1 up, that asymptote that was on the x-axis is going to be pushed up 1. And then all of these points, these 3 points, are pushed up 1. And I'm going to try to graph this with this tablet I have. And there's the graph of f of x. Over here we have e to the x. So e to the 0 is 1. E to the first is 2.718, so just short of 3. And then e squared is just a little over 7. 1, 2, 3, 4, 5, 6, 7. A little over 7. Now, negative on the inside reflects over the y-axis. So reflects over the y. And then push everything up 4. So 1, 2, 3, 4. This is where that horizontal asymptote is. Right here. And then up 1, 2, 3, 4. 1, 2, 2.718. And let's see, 1, 2, 3, 4. So pushed up somewhere up there. So here is the graph right there. How about log? Now, when we plug values in for logs, we want powers of the base. So like I would plug in 1, 3, 9, 27, 81. We could keep going on with powers of 3 in this case. So the parent graph would be 1. 3 to the 0 is 1, so we have 1, 0. 3 to the first, so we'd plug in 3. That'd be 3 to the first. Then we'd plug in 9 would be a good value. And then we push all of those up 2. So up 2, and up 2. And that vertical asymptote, that is the y-axis, it stays there because we didn't push left or right. We just pushed up. Over here on letter D, we're going to have to rewrite this. We have the natural log. Remember, the variable on the inside needs a coefficient of 1. So we have x plus 2. And we have a negative on the inside. Let's get the parent graph. We have 1, 0. 2.718 is 1. A little over 7. 1, 2, 3, 4, 5, 6, 7 is e squared. So there's the parent graph. Now we're going to reflect that over the y-axis. So over here, 1, 2, 3, 2.718, and 3, 4, 5, 6, 7 right here. And so that's reflected over the y-axis, and then we have to go left 2. So 1, 2 right here, 1, 2 there, and 1, 2 about right there. Well, that pushed that vertical asymptote that was on the y-axis, that pushed that 2 to the left as well. So make sure you have those asymptotes if they move. And like that. Evaluate log base 4 of 4 to the 5th. Well, those have the same bases, so that's just 5. These have the same bases, so this is 2x plus 3. This is asking 27 to what power is 3? Well, 27 to the 1/3, the third root of 27 is 3. So the answer, that evaluates to 1/3. Natural log is base e, so these have the same bases, and that's just going to be 3x. 3 to the 4th is 81, and we need to get that 81 to the denominator, so that's 3 to the negative 4th. So that evaluates to negative 4. 9 to the 0 is 1. On this one, we got log base 4 of 4,096 is equal to 6. And right here, write an exponential, 16 to the 7th is equal to a. Keep in mind that logs always equal the exponent. So the exponent on this one was 6, so the log has to equal the 6. And right here, log is equal to the 7. That's the exponent. Expand this, All right, well, let's do this first. Let's go log of r over xy squared to the 1/5 power. Now let's bring that 1/5 power down in front. R over xy squared. Excuse me. Let's expand this out. So we have 1/5 times log of r minus log of x. And since y squared is also in the denominator, let's go minus log of y squared. So we have 1/5 log of r minus 1/5 log of x. And then minus, now if we bring this 2 down in front, 2 times a fifth is 2/5 log of y. Over here on letter B, we have natural log of, let's do it like this, square root of r squared plus 3 minus natural log of 3 minus natural log of s. And again, since both of those are in the denominator, they're both going to be minus. Now this is to the 1/2 power, so we're going to go 1/2 natural log of r squared plus 3 minus natural log of 3 minus natural log of s. Condense, let's go backwards with it. Let's do the brackets first. We have 1/3 natural log of x over x minus 1 to the third, because we can bring that up to a power, plus 1/5 natural log of x. So this is going to be the natural log of the third root, because this is to the 1/3 power, third root of x over x minus 1 to the third, and then times the fifth root of x. And that's the natural log of both of those. Here we have log base 2 of x plus 4 times x minus 2. So it's log base 2 of x squared plus 2x minus 8. Simplify this one. We have the natural log of e to the 7/5, because the root part is going to be the denominator and the power is going to be the numerator. So this evaluates to 7/5 because they both have the same base. This one over here, we have log base c of 5c to the 8th to the 1/2. Square root, 1/2, same thing. So we bring the 1/2 down in front. We have log base c of, let's do it like this. We're going to bring it down in front, but then we're going to go log base c of 5 plus log base c of c to the 8th. And we have 1/2 log base c of 5 plus 8, because those are the same bases. So we can write 1/2 log base c of 5 plus 4. Determine the amount of money that should be invested at a rate of 4.2% continuously to produce a final balance of $35,000 in 18 years. So amount of money that, well, they want $35,000 in the end, and they're asking, well, how much principal would you need to accomplish this? Now it's continuous, so it's the PERT formula, e to the 0.042 times 18. Let's open up the calculator. Let's see where this opens up. There we go. And we have 35,000. We're going to divide by e to the 0.042 times 18. So $16,433 and some sort of cents, 92 cents. Determine the principal that must be invested at a rate of 6.8% compounded monthly, so the balance in 15 years will be $35,000. So $35,000 is equal to the principal times 1 plus 0.068. Now this is going to be monthly, so we're going to divide by 12, raised to the 12 times 15 years. So let's grab the calculator, and we got, let's do this. Let's go 1 plus 0.068. We're going to divide that by 12. And then we're going to raise this to the 12 times 15. And then 35,000 divided by that answer. And so we'll have to invest 12,657. 12,657, and let's see, what was the cents? It was 21 cents. An ant farm has an initial population of 124 ants. Over time, the population grew continuously at a rate of 12%. What is the population of the ant farm after 8 years? So the population, or the number of ants, equals the initial amount, e to the RT. And it's the PERT formula, except we're not working with money, so we don't have this as the amount and that as principal. We just have the initial amount, and that's equal to the amount over, in the end. So in the end, we'll have 125 e to the 0.12 times the 8 years. So 125 times e to the 0.12 times 8. So 326. So 326, and now this is a statistic, so we can have, 0.46 as an answer. Ants.